our experiment is of sand casting. That is, we have to perform sand casting. So the first step in sand casting is the pattern. It means that before we start our sand casting, it is very important that we have a pattern of desired dimension. So before we make any pattern, we have to go through some allowances. So there are basically five allowances. That is, the first one is shrinkage allowance, second one is machining allowance, third one is taper allowance, fourth one is shake allowance, and the fifth one is distortion allowance. These are all these allowances which we give to the pattern. The desired dimension of pattern and the original product that we get at the end of sand casting are different. First we will discuss about what is shrinkage allowance. So as the name suggests, the shrinkage allowance means whenever the metal is in liquid state and when it cools down to the room temperature, the metal shrinks, which means that if we make the pattern of bigger size, then it will shrink and it will become smaller. That's why we give allowances to the pattern. The positive sign suggests, here I have written positive, it means that this allowance is positive, which means that in order to get the desired dimension of our product, we have to make our pattern bigger. That's why I have written here positive. So we will understand more deeply about the shrinkage allowance next year. So you can see that this is the temperature and this is the time graph. So whenever we heat a metal before sand casting, the temperature are generally very high. This is the melting point temperature, and we usually you can see that this is the melting point temperature. I will write here as Tm. This suggests that melting point of temperature. Suppose we have taken aluminium. So the melting point of aluminium is around 618 degrees Celsius. So when we are doing sand casting, we will melt that aluminium in the liquid state, which means that the temperature will be around 900 degrees Celsius. So whenever when the temperature cools down to room temperature, first of all, this temperature will come down to the melting point temperature, which means if this is 900 degrees Celsius and this is 650 degrees Celsius, suppose, then and this one is suppose room temperature. This one is room temperature. Then what happens is metal will cool from liquid from 900 degrees Celsius to 650 degrees Celsius. Then there will be shrinkage. That shrinkage is called liquid shrinkage, and this is compensated by the riser. Then again, at this temperature, at the melting point temperature, we know that the temperature remains constant, but the phase changes from liquid to solid. So during this time also there will be some shrinkage. This shrinkage is called solidification shrinkage, and this will be compensated by riser. That is why we use riser. So basically the main aim of riser is to first compensate the liquid shrinkage and solidification shrinkage. Apart from that, gases also come out from the riser. This is another function, but the main function is this. Then further from the melting point temperature to the room point temperature, there will be one more shrinkage that is called solid shrinkage, and this solid shrinkage is compensated by pattern, which means that we have to make the pattern bigger so that after the solid shrinkage, we will get the product of desired dimension. So, for example, for aluminium, the solid shrinkage is 16 to 18 mm per meter. In our case, that we have used that aluminium, so that aluminium has 18 mm. I mean 18 mm per meter, which means that for 1 meter product there will be 18 mm of compensation. That is called solid shrinkage. So now the second one is machining allowance. So as the name suggests, the machining allowance means that we make the product bigger size so that at the end we can do the machining and the finishing of the product and we get the desired dimension. For example, let us suppose that this is our desired dimension of 10 mm by 10 mm. But we cannot do the casting of 10 mm directly. We have to take a pattern that is more than 10 mm. Let's say a pattern of 12 mm by 12 mm, so that when we do the casting, at the end there will be lot of defects at the surface, and after machining we will do the machining, and machining like milling, facing or turning. There are various machining processes and polishing. So after doing that, we will eliminate this extra part, and at the end we will get by 10 by 10 mm. So in our case, the machining allowances is 4 mm per side, which means that suppose this is the desired dimension that we needed. So in our case, what we have taken is that we have taken the machining allowances of 4 mm. 4 mm means 2 mm from this side and 2 mm from this side. So what we do is, in pattern, simply we add 2 mm plus 2 mm 4 mm. So each side will be added 4 mm to compensate the machining positive allowance. Why? Because we are making the pattern bigger than the desired dimension. That is why we call machining allowance as a positive allowance. There are other three types of allowances like taper allowance, shake allowance and distortion allowance, which in our case is negligible. I will tell you why. The taper allowance means we make our product taper so that we can easily remove from the sand mold. But our product is of small dimension and taper allowances here is neglected. If we talk about the shake allowances, it is called negative allowances because this allowances is given to the mold, which means that if we have to remove this part from the sand mold, we will definitely shake it from the sand mold and remove it. But when we will shake it, the mold dimension will increase slightly. But in our case, again our product is of a smaller dimension, so shake allowance is usually in our case is very small and it can be neglected. And again if we talk about the distortion allowances, then this is usually given to casting of sheets or thin metal sheets. But in our case, our product is not a thin, so again this is usually neglected. So these three allowances are very small in our case, and it did not need to be considered. But the main allowances are shrinkage allowance and machining allowance. Now we will see the calculations of various allowances here. You can see that this is the desired dimension, that is 19 by 60 by 12. This is the desired dimension. Desired dimension is 90 by 60 by 12. So this is our desired dimension. But in order to make, but first of all we have to make the pattern, and in pattern there will be allowances. So if we consider the allowances, the pattern length, width and thickness will be greater than the desired dimension. And you can see here that I was talking about the machining allowances, so 2 mm from this side, 2 mm from this side, so total is 4 mm per side. This is only for machining allowances. Now we will calculate the total dimension of pattern. So here you can see that how we calculate the length, width and thickness of the pattern with this formula. So length of pattern LP will be length of desired dimension plus 18 by 1000, that is the solid shrinkage of aluminium, 18 by 1000 multiplied by length of desired dimension plus machining allowances. So if we calculate, that is 90 plus 18 upon 1000 multiplied by 90 plus 4. This is the machining allowances. Then we get 95.62, which is close to 96 mm. Our final pattern will be of 96 mm. Similarly, if we calculate the width of pattern, then this will be W plus 18 by 1000 into 60. 60 is the original dimension, that is W. Width of the desired dimension. 60 is the desired dimension. So W plus 18 by 1000, as 18 by 1000 is solid shrinkage of aluminium, into 60 plus machining allowances. Machining allowances is fixed, that is 4 mm. So if we calculate, put the values, we will get 65.08 mm, which is close to 65.1 mm. If we calculate the thickness, that is thickness of pattern, again similar formula, thickness plus 18 by 1000 into T plus machining allowances. This one is constant, that is 4 mm, and this we will calculate 12 plus 18 by 1000 into 12 plus 4. We get 16.21, which is close to 16.5 mm. So we can see that the desired pattern dimension will be 96 by 65.1 by 16.5. So in our case, we will make the wooden pattern of this dimension, and in further videos, in further experiment, you will see that this dimension will finally be converted into the final product, that is desired dimension 90 by 60 by 12. So you can see that the dimension of pattern is more and dimension of original product is less, because we are taking some allowances. But at the end, after the casting, after full machining processes, we will get the desired dimension. I think I have covered all the allowances, and we will see everything with experiment, with complete experiment, and at the end we will find what is the importance of allowances in sand casting. Thank you.